So this is Hack Machine Learning, hacking your Facebook data. We'll pass that time. I'm Bernease Herman, and my GitHub account is there at the bottom if you guys need to make it to the files. So, as I mentioned earlier, we should have downloaded this file, collab.py. Let me open it up in I'm going to open mine.
Not see maintenance.
Okay. So that file should have somewhere on your desktop. Okay. So beginning with what is machine learning? So anyone have an idea? You can kind of cheat because this is a little different still. But anyone have an idea of what's machine learning? Or can you sentence yourself? Cool. Okay. So it's an idea of, I mean, if you think of artificial intelligence, it's kind of the data side of artificial intelligence. Or essentially, you want to predict things using the computer, using your data without hand coding everything. So the point of this is if you're doing a hack, let's say anyone going to Hack NY or anyone going to any hackathon, you may have an app that could use something like grouping things together, suggesting friends or whatever, and machine learning is great for that, learning from data. So what machine learning is not is data mining. So machine learning focuses on like prediction, so you kind of know all the things you have. So on Facebook, you know your friends, you know how many times they commented on this, what like things they liked, but you want to predict something else. Data mining is a little different. It's very similar techniques, some of the same techniques, but instead what you're going to do is you're going to, you have all this data, you're really kind of finding some hidden patterns. And that's from Wikipedia, these two definitions. So, machine learning versus big data. I heard some of you guys say big data there. There's a lot of big data techniques that you use in machine learning. So, if you have enough data, you have to use parallel computing, clustering, but we'll learn a different definition for clustering later on. Information architecture, a lot of different kind of techniques. But it is a myth. This is a myth. It's not the size of the data, but the way you use it. That's not true, right? So, I can say it for other things, but so essentially, the more data you have, the easier this learning is going to be, right? So you can find the best algorithm to describe these things, but if you only have a little bit of data, it's not as good as, you know, a crappy algorithm with a ton of data. That's why a lot of companies, they're actually looking just for more data in quantity versus trying to make their algorithms better at some point. All right. Out of time? Okay. So, defining the problem. So, whenever we have a machine learning problem, we have two things. We have a feature set, which is, I mean, essentially like your independent variables if you think of back to stats or back to any formula. And then you have your label, which, you know, so if you say y equals mxb, y is your label, x would be your feature. You can have other features. That's your dependent variable. So machine learning techniques kind of break down into three things, two kind of main categories. So supervised learning, which what this is you're trying to make a model, and you have a ton of, you have a lot of data, but you have a lot of data with both the independent variables, so like the x's, plus the y's. And now you're trying to predict some other set of x's. So, I mean, if you guys know linear regression at all, you know, you have a lot of points. You have the x and the y for a lot of points, and then you're trying to predict the y for some particular x. So that's an example of supervised learning. Semi-supervised learning is in between the two. It's kind of like you have the extremes. Maybe you know, like if x is all the way to 1, you know what y is. If x is all the way to 0, you know what y is. But you don't know anything in between. So you use an algorithm to kind of come from the extremes and fill everything in. Unsupervised learning, which is another one we're going to go over, you don't have any label data. You just have a ton of x's. And you're like, hey, let's sort these. Let's do something with these. So we're going to touch on unsupervised learning, and we'll touch on supervised learning. Any questions so far over the last couple of slides? Okay. And I'll give you guys time to get the file up and things if people don't have it up. Okay, so the first method we're going to talk about 3 methods pretty quickly, and then we're actually going to go through and look at the code for one of them. So clustering. So right here we have XY plane, right? And we have a ton of data points. So in this example, we don't really know anything about the data other than these X and Y's. So one thing I will clarify, for these next 3 examples in this picture, these, typically you think of like X, Y coordinate. This is our independent variable, this is our dependent variable, right? We're going to do it a little different. So, because normally you'll have a ton of X's, and I don't want to make this into 13th dimension, we're going to keep this in a 2D plane. This is X1, this is some X2, some other X. And then the Y value is actually shown by the shape of the dot. So right here, all of these are circles. But in some other examples, you'll see circles and X's and different things. Those are the Y's. So these are both X's. Just heads up. Okay, so clustering. So here's an example of, we have some data. We have 2 features. Here's some example features. Okay, so this is our Facebook data. We have, let's say we're looking at our posts, right? Okay, all my posts are either about sports, politics, or coding / homework. Pretty much the same. So let's say like we're going to isolate 2 features of this data, okay? So our feature set here is whether or not the post is positive or negative. So whether it uses words like good or horrible or things like that. And then excitement, just sheer number of exclamation points, capitalization, how extreme the words are, moderate, something like sure, that's kind of in the middle. So these are on the scale of these 2. So something right here, like this one, it's extremely positive, right? So we have positive there here. But it's not very exciting. So that might, I know you can say what you will. Versus something over here, where it's extremely exciting, and it's a little more negative than positive, but it's not extremely negative in any way. So I was going to let you guys guess which one would be schoolwork, which one would be politics, and which one would be sports, but it's up to interpretation. So clustering, what clustering does is it takes our data from this. Ooh, that's why I skipped one. Okay, so it takes our data from this to this. So it's saying, okay, we're grouping these together. Maybe these are, show these again. Maybe these are less exciting but negative. Politics. Not super excited about politics. Not really happy about it most times. Versus positive but not exciting might be coding / homework. I don't really say negative things about homework. And then normally I'm excited, but it could go either way for sports. So this is how the algorithm did all of this clustering, and I'm showing by the different colors. So these have different Y values. Okay, so now we're going to learn about a clustering method, and I apologize for not putting the name up. I will type it out for you guys. Don't know why I didn't put the name up, but this is the PDF, so I can't do it now. It's called K-means. So essentially what K-means is going to do is we're going to say, hey, we want to cluster our original data without the colors into however many K number of groups, okay? So I'm keeping the colors up for you guys just so you know, so you have an idea of like what our final result is going to be. It's a lot easier to understand the algorithm. But let's just begin. So we're going to let K equal 3 randomly. Normally what you do if you're going to actually run this algorithm is you'll have a set and you'll run across all of them, and then you'll go back and validate and see which ones overfit, things like that. But we know it's 3, we're looking at it, we're going to say 3, K equals 3. So now what we do is we pick 3 random spots, these black dots, say, okay, these are the middle of our clusters. They clearly don't look like it now, but we'll get there. Okay, so now what we do from there is we just use a distance, Euclidean distance, to find which points are the closest to each spot. And we're going to say, okay, these are all part of cluster 1, these are all part of that cluster, those are all a part of that cluster. And notice that some of the wrong colored ones are in the original clusters. Okay, next the algorithm goes to the middle of those clusters. It's kind of hard to see. So this cluster right here, let's say the middle is like here. All of these dots are saying, okay, those are part of the cluster. We're going to go to the middle. So now these are in the middle of what we found our new clusters. And we're going to iterate. So we'll do it again. And then we get here. And we'll do it again. And then look, all of these clusters have its correct colors, right? The algorithm doesn't know that. But what it does know is that when you grab all of these, and there's no changes, right? So this dot isn't going to move. The moment that all 3 dots don't move, you're done with your algorithm. That's clustering. So some examples for clustering would be, let's say we took our posts and said, hey, I want to break them up into, like I said, sports, politics, coding, something like that. Anything else. You could break up like the things you like into TV shows, blah, 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 whatever. Those kind of things. So it's taking groups that you have no information about other than these like kind of factors and clustering. Next one, classification. So classification, notice these have different Y values. Classification works like this. Let's say an example, Facebook events, okay? So if you get a Facebook event, it's quite possibly spam, quite possibly not. So we're going to say how the X's are spam or Facebook events you wouldn't want to be invited to. The circles are ones you would want to go to. This algorithm will figure these out. So anyone have an idea of like, how could you just kind of look? Let's say I found one that, here I'll show this. So this is number of friends that declined, percentage of people who responded in general. So just pick these out of the hat, whatever. Let's say something fits right here. How could I predict whether or not this is going to be a circle or an X? I'm going to make someone respond for this one.
Somehow form some barrier between the two clusters.
Okay.
And if it's on some barrier,
Mm-hmm.
that's the first group.
Yeah, awesome. That is actually, so there's a thing called vector machines. So linear vector machines will make a line and they'll kind of take a line and put that there and see what side is on the line. So support vector machines do the same thing, but you can do it quadratically and things like that. That's awesome. Those are actually very complicated machine learning algorithms that you would use if you were good with them. So we're going to do something even more simple, way simpler. We have a dot here. Let's see if I have a dot here. I don't want to cheat and show you guys. Oh, well, look at that dot. If we have a dot there, how do I predict?
See what the closest other dot is.
Yeah, okay, so if we pick the closest other dot, that's a circle. It's likely to be a circle, right? But you can end up overfitting, right? So let's say there's a lot of X's over here. Let's say I happen to put an X right, or a dot right here, right? They're mainly X's over here, but that one O kind of throws it off. So you overfit. So what you want to do is take K number of closest and then find the percentage, right? So in this case, I think I just randomly picked 5. So that dot, you pick the 5 closest, and you notice 4 of them are circles, 1 of them is an X, probably going to be a circle. And I put an X because I am an idiot. Should be a circle. Okay. The last one, and this is the one we're going to actually do, is collaborative filtering. So you guys are familiar with, like, on a website when you personalize things. So it may say, hey, well, let's say Spotify. Hey, so-and-so liked these songs. You'd probably like them too. Or you know, on Amazon, so-and-so liked these books. You probably would like them too. Anything that's taking, this is like the personalization, recommendation system type of thing. And this is how it's going to work. So these are, I think the best way to think about it, and we'll change the example up a little bit later with Facebook. The best way to think about it is like movie reviews, okay? So, show you that slide. Okay, so what you basically do is you're going to plot your friends' rank and the rank you have for any movies you've reviewed, and then you're going to kind of come up with some kind of model. So, for example, let's say, I don't know, let's say this is a bad movie. We both think it's bad. I don't know. I'm going to pick someone so I have a name. So Michael. Michael hates whatever this movie is, and I hate it as well. Michael kind of likes this movie. I still kind of hate it. Michael kind of really likes this movie. I think it's mediocre to good. So these are plotted this way. And you would do that for all of your friends that you had their movie reviews, okay? The next thing we would do is put a line of best fit. So straight linear regression. If you guys don't remember linear regression or have never seen it, essentially what this is doing is putting a line so that this distance squared, so this, well actually this y value squared between each x, we're trying to minimize the sum of that. So that's how it works. You find the line in which it's closest in y value to all of the x's. Okay? I think that's going to be the last one of that. So we are going to do collaborative filtering, but we are going to do it with our Facebook information. So what I thought of, actually today, probably way too late, is we are going to take our posts. Okay, so let's say your friend posts something, right? And a ton of friends go on and they like it, and a ton of other friends go on and comment it, but somehow it like got past you on your feed. No one reads their entire feed. So those are important, right? You want to see those posts. So what we're going to do is we're going to make basically a recommendation system for specific statuses that people post. So if Liz posts something and a ton of my friends like and comment on it, we're going to use this system to rank it. We're basically ranking it a 0 if they didn't like or commented on it, a 1 if they liked it, a 2 if they commented on it, and a 3 if they liked and commented on it. So we're going to do that with all of our friends and add those up. We don't want to add those up kind of on their own, right? Because some of my friends have more similar tastes to me. So what we want to do is then go kind of find a similarity measure for each friend between myself and my friend and multiply that by that. Any questions just on concept before we actually go into the Facebook data? Then we get to play with the Facebook data. Fun part. Any questions at all? Michael?
Can you say that again?
Yeah, no problem. Okay, so how collaborative filtering works is we're comparing how my friend ranked it versus how I ranked it. So these are the things, in the movie reviews example, this would be the thing, like this is a movie that we both ranked, this is a movie, all of these X's are movies we both ranked. So now, there are other movies that you have ranked that I haven't ranked. So for those movies, I can multiply our kind of how similar we are to by what you've ranked it. And then add that up across all of my friends and then see which ones come out at the top. Those are the most important movies for me to see. So in this example, this is the most common way to do it with the linear regression. And actually the similarity measure is really nice because it's the slope of this line. Or not the slope, sorry, I apologize. The R value of this line. So that's actually the fit. It goes from -1, which is actually perfectly fitting but downsloping, to 1, which is perfectly fitting but upsloping, and then 0. So a 0 would be like a mess of X's that have no kind of linear relationship whatsoever. A 1 would be a perfect line. So that's how you would rank my similarity with a friend. Okay, so now on to the Facebook data. We're going to pull it from the Graph API, Facebook. So we're going to all go to this website, possible, and you have to be signed into Facebook. And if you're a college student who doesn't have Facebook, I congratulate you, because that is no one though. All right. I have a friend who doesn't have a Facebook page.
How do you know he's your friend if he doesn't have a Facebook?
Well, because I have friends in real life too. So yeah.
What's that?
That's another workshop actually. So I'm gonna do that later.
I think I need that one more.
Okay, are you guys all seeing this? This is a developer's page, but you should be able to get to it if you don't have a Facebook developer. Just want a nod, just a single nod or a head shake.
When we click submission.
Oh yeah, so that's going to be the next step, and I don't have a picture of it, sorry, because I was too lazy. So I went through and clicked everything, but let me go and yeah, I can go and show you which ones you need. I've been playing with this Facebook data for a long time. Sorry, I'm really confused. I don't have a thing up. Yeah, I do. I tried to type really fast so you guys don't see anything. Okay.
And then when you're done checking out,
Developers, Facebook
and
tools.
then check out the boxes.
Okay. All right, so you guys should get here. So, just for future reference, if you guys want to play around with this, you can click this little plus sign and see all your information. So first I'll show you this. The first thing you want to do is you're going to hit get access. And you're going to get this pop-up. This is what you're talking about, right? So I clicked everything because I was being obnoxious. You actually only need, you didn't need any of this. You need user status. And you need, in the friends data permissions, you just want friends status. Friends status. Yep, that's all you need. I don't think there's anything in here you need. Read friend list. No, you should need that. Or you can be played safe like me and just click them all. That's what I do. Less thinking. Okay, so when you're done with that, click Get Access Token, and you should get a new access token up here. And you'll have your node here. So if I hit this, I hit Submit, you'll see all my information. Name, first name, blah, 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 birthday, hometown, jobs, high school, all these things in there.
Is that because you have no specific field selected?
So yeah, that's because I have node here, which is node. You can either use node or me. That's not how you spell me. And you have no specific field selected. Yeah. Sorry, I really want to say that. You can click the plus sign and look at other fields that you want. Friend list, feeds. I don't really care. Events. Boom. These are events. Pi Day, into college rager. Wow, I thought Hack Machine Learning would be top, but Hack Machine Learning is the top. Let's put Pi Day on there for like 2015. Okay, so now that we have this is what we need to plug into our collab.py. So actually, let me scroll through this. Okay, so open your collab.py file as well, and put it in a place that you know where it is, where it's easy to get to. You don't want to type folders and folders and folders. Or you can do it once. Does everyone have everyone has their collab.py? Does everyone know how to get to their terminal? Liz, do you know how to get to yours? No, I'm going to show you. Are you caught up right now?
Probably not close enough.
Yeah, you can.
Okay, so does everyone have it? Okay, so what we're going to do is I put a little orange square, so you click Get Access Tokens. We already did that. Now we're going to copy our access token into our Python file. I need to get out of this and actually do it. So copy this here. Sorry. Green happy. Okay. Boom. Really low. Okay. How am I moving so fast? I apologize. Okay. So the next thing we're going to do is you see this ID number, this top ID number? On my slide I have this. If you still have your node, your number next to node, you can use that, or it should be the first thing in ID. You want to copy that and put it into my ID. Let me do that. Okay, Hoping everyone has it in there. Okay, so I put a sense date of March 15th. You guys can put however far back you want to go. Don't do something super obnoxious. It will take forever to load. I will change it to the 1st, just to be different because I'm tired of seeing the same data. So now we have minimum likes and minimum comments. So I'm going to explain a little bit about how this algorithm is going to work. Essentially what we want to do is we want to look at all of our friends' statuses. And we want to see, okay, how many people have liked it? How many people have commented on it? And did I like or comment on it? If I liked or commented on it, we want to see, hey, whoever else liked or commented on it must be pretty similar to me. And we're going to add to their similarity score. So that's how we're going to populate their similarity score. We're going to keep going through all of them and saying, hey, if we both did the same thing by liking or not liking, or by liking or commenting, we must be pretty similar. So, sorry. From there, what we're going to do, we have our similarity score, like we mentioned, with collaborative filtering. Then what we're going to do is we're going to go through and multiply these similarity scores by, for each post that one of my friends has liked or commented on that I haven't, we're going to go through and we're going to say, hey, this post, above our minimum likes or comments. So we don't want to do ones that no one commented on. I'm going to increase this from 1 and 1. Probably should 2. I'll say at least 3 people had to like it. I don't need any comments. My friends aren't super commenters. Well, we'll say 2. Just
right now we're developing like the training data. Is that the word?
Right. So for collaborative filtering, it's supervised. So essentially, like everything's training data. We're not really gonna go through and verify this. So normally, what you would do is you have training data, you have testing data. Your testing data is either subset of your training data or different set, and we would say, hey, how legitimate is this model? We're gonna train it, then we're gonna test it with our model, and then we're gonna see how right it is. I'm not gonna get into like the training and testing, so we're just gonna treat everything as training data. We're going to make our model from there. And we're going to check. But yeah, so normally what you would do is you would pull out a subset and say, hey, we want to see if this overfits or not. Let's pull some out and then check the model on the data that we already have the answers to, and then check and see how accurate those answers are. But for this one, we're not. So yeah, so just set your minimum likes and comments to something decent. I don't know how often your friends like things or comment on things. So now we're going to kind of go through this. It's really simple code. I was going to have you guys code it, actually, but we'll just go through it and catch up. First thing we're going to do is, I shall show you what format this data comes out in. So, data comes out like this. I don't know if you guys can see that on the screen. It comes out in JSON format. It's kind of like, if you've seen XML or anything, it's kind of within tiers with dictionaries if you use Python or hash maps. So like within your data tier, then you can go inside of it and say, okay, now look up name, name is a key, and then from there you'll get your answer, which is machine learning. So this all the way down. That's an example of the events thing that I showed you guys. So first thing we're going to do on line 17 is we're going to pull in the JSON. Now we're going to convert it to Python dictionaries and lists, and then we're going to clean it up. Does anyone have any questions? Okay, cool. So we're going to clean it up, and what I mean by cleaning it up is, let me actually open these. I'm going to actually open this up so you guys can see what the file we're working on looks like. This is my idea. Okay, so this is what the file with our friend list looks like. Boom, just IDs. I decided, I mean, this is a script, right? So it doesn't really need to see the names, but you can put the names in if I wanted. And those are a list of my friends and their IDs. So everyone did that with their Python file. Well, they will when they run it. Yeah. Okay, so it's going to load that file up that I showed you and clean it up a little bit. And what I mean by cleaning it up is we have a lot of kind of unnecessary, it's kind of really heavily tiered. So we have ID, then we have friends, and then within friends we have a thing called data, then within data we have these structures that have IDs and names. And originally we had ones that just had IDs, so that's already a structure that's unnecessary. So, so in the cleanup, all I'm doing is taking friends, I'm going inside of the friends bracket, going inside of the data bracket, and then we get these ID dictionaries. So the first thing you're going to do is it's going to print how many friends you have, because it's already fun to see. If you were here early enough, I had 992 friends when I started running this, and then by the time I was done set up, I had 991. So someone has already unfriended me. I'll have to figure that out later. So we're gonna create this thing called friend sim. And what this is gonna do is gonna hold all the IDs of all of your friends you have on your list and zeros. These zeros are gonna eventually be your similarity measure that we're gonna measure out. Total sim, the only reason I'm keeping total sim is we're gonna divide by total sim when we figure out how many things. Essentially, this is just going to be how many statuses we look at, and then we're going to divide it then. So, for each key pair and friends, and what I mean by key pair and friends is, I'll just take this out for a second. Okay, so we have all these key pairs. Inside of brackets in Python will be a dictionary. So you'll have a key, which is ID, and then you'll have its value, which is this, and all these different ones. So for each of these little key pairs, we're going to add the key pair ID to friendsim with the value of 0. So we just go through all of them and do that. Then we're going to take the list of keys, which are all these key pairs, and make a friend list. There's a faster way to do it using zip, but I wanted to show it out so you guys knew what it was doing. Okay, so now we're going to create a dictionary. Even though I said dictionary, it's clearly a list. So we're going to create a list of unseen posts. And so this is eventually what we're going to push whenever we're going to look at a post, and we're going to say, hey, I didn't like this post, or I didn't comment on this post, but some of my friends did. Let's push it to unseen lists. Now I have to change my code because, whatever, we'll see. Okay, so so for every friend inside of our dictionary, we are going to do a similar thing that we did with the friends list, right? So we're going to open a file that's pulling from the Facebook API, showing this, showing a particular friend's all their statuses, the comments, and how many likes you have on it. I'm going to show you guys an example of one. Does someone want to volunteer to show theirs? Because I don't want to show anyone's data that doesn't want it to be shown. This is your statuses. If not, I can show mine. Okay. All right. No little volunteer.
Yeah.
Okay, so what I'm going to need from you is, this is mine. Okay, what I'm going to need from you is your my ID, Noah.
Okay. 1 0 0 0 0 0.
1 0 0 0 0 0.
5 zeros. 7 8 6 4 4 5 7 5 7.
A lot longer than mine, but we'll see if that's fine. Okay, statuses says whatever date.
Usually there's 7.
Yeah, you have to do
There's no more 7.
Yeah.
Oh,
You end with a
5, 7, 5, 7. Okay. This, okay, and my axis too. Which I could have kept over there, but I forgot. Okay. This takes a little longer to look. Okay, so this is what we had. So we have our ID, a friend's bracket that's going to be unnecessary data bracket, and inside of that, a friend's ID, all these things. We're going to go inside, finally see Noah Cohen, the most recent message he had, when it was updated, all of the people, so the names and the IDs of all of the people who liked it. Then you have this paging thing that's actually for if you're making an app. You might want to link to the next, it only gives you a certain number of them. You might want to link to the next set of them. You can also tell them explicitly how many you want. Then inside of comments, so that now you have the comments, you have who commented, oddly enough it was him the first time, and what time they commented, things like that. How many people liked that comment, whether or not you liked it. At least you didn't like your own comment to your own status.
Like your own comment. Change
So-
that.
Yeah, what's that?
Who else commented? Things like that. Okay, and so we go down. Here's the next message. All the same stuff. Okay? You guys got to get the structure of how it's coming out? Cool. Woo. All right.
You're not doing anything with like similarity yet, you're just pulling all of his stuff.
Right, yeah. We'll do similarity about. We're going to move it moves a little faster. Started kind of in a little bit. Okay, so we created a friend list. We're pulling in these friends. So we're opening that URL, converting it to Python. Then we're going to check and see if they don't have any statuses. Because I had a friend randomly at the top that had no statuses. Delete them out. Clean it up a little bit, go kind of further into the brackets. Now, for each status, what we're going to do is we're going to create a unique list of likers. So the people who liked the status. It's actually not unique there. We're going to make it unique a little later, but that's fine. And then for each commenter, we're going to do the same thing. We don't really care about the comments. We just want to see whether or not someone commented. If it's liked or commented, so if my ID is in the liked list, or if my ID is in the commenter list, we're going to add to our total similarity. This is just to keep track of these things. Keep track of how many we have, so when we divide it to get a percentage. And then for each liker in the like ID that's not myself, I'm going to add one to their similarity points. For each commenter, they're going to add 2. So if they're in the like list and the comment list, they'll get 3. Otherwise, if I didn't like or comment on it, I'm going to push it to my unseen post list. So
if you liked the comment,
mm-hmm.
are you adding one to the friend similarity list? Or I see you're adding to the total similarity?
Right, so if I liked the comment, then that means if I like the comment and one of my friends added the comment, then we're similar. We're more similar than I thought we were before. So that's the only time I want to add to our similarity.
Okay.
Otherwise, I'm going to push this to our unseen post list. So I did realize there is a line of code that I did not put in, I think because I just wanted to see more pieces of information, and that's using our two thresholds that we made. So the minimum number of likes and the minimum number of comments. If you want to add that in, and you know Python a little bit, you can go ahead and add that in and say something like, if min comments, min likes is greater than or equal to, sorry. We'll say if the length, the likes, which is actually len status. Sorry, it's obnoxious. I think this was earlier. Likes data. So if this would be the number of your likes, so the length of go into the status thing that you already made, how many likes, the data, and this would be how many structures are inside that. If that's greater than or equal to 10 likes, and if we're going to do the same thing but with comments, and then make sure you change comments inside of the actual key. Make sure you spell everything right. Just that down there so you can see it. So if that's the case, bracket, then in Python they're very white space conscious of push. So I'm going to push everything beyond that in one. So this is the line I added. If length of status likes data is greater than or equal to minimum likes. If the same thing is true for the comments, then we'll push it to unseen posts. That way you don't see a list of all of the posts that I haven't seen, which is why mine showed everything. Yeah. I'm going to give everyone a second since there's some typing, or is everyone pretty good? Or they're just not going to add it? Okay. So I'll leave that right there. So then what we're going to do, this is actually the end of our brackets. So that's all we did. Sorry for moving this around a little bit. For each status, we went through that whole thing, and then for each comment in the status, or yeah, for each comment and like in the status, we did these things. So we're going to do all of that for each status. Okay. So from here, we just have a couple more lines. We're going to take our friend ID. Sorry. We're going to take our friend ID and divide our friend sims, all of our friend sims, by that total we had. That way we get a percentage. And then for each post in our unseen post, what we're going to do is we're going to go and we're going to multiply our simulation number by 1 if they're the liker. So for each friend, what we're going to do is if they're the liker, we're going to go in and multiply it by 1. If they're the commenter, we're going to go in and multiply it by 2 for each liker commenter for each post. And then what we're going to do is we're going to sort the posts in our unseen posts by the similarity score. And then we should print the result, and we'll have the posts that we should want to see most to the posts we want to see least. So, because I made some changes and I have this amazing ability to never make a change to anything and get it to work, let's go and run it. So I'm actually, there's 2 ways to do it. It's a little harder if you try to do it within the Python command line. The only reason that is we'd have to go in and change our path and make sure it includes this file wherever we put it. So if you can all get to your terminal, it's a lot easier. You can just say Python file. Otherwise, I'll go through and show you how to add it. Can everyone get to the terminal? It'd be lots of fun.
What about Windows users?
Windows users probably want to go and add it. Does anyone Python and Windows very often? I do.
I don't know.
Right, but they can't get to the terminal. Well, no, you can get to your terminal. Yeah, then it works the same way. I don't use Windows. I just stay away. You can get to your terminal. And if I ever do use Windows, it's on our campus computers, and we've lost it. Okay. So I want to make sure everyone got to the terminal. Liz? Oh, okay. So you got it.
You have to fix this. Hey, mine's still good.
So you say run collab.5?
You just have to type down the file like that. I have it.
No worries.
So you're in the Python terminal, you want to exit out of the
Yeah, exit Python.
It's just like an
Yeah.
Alright, so now.
Open. I think I
Yeah,
may
you
have
get to wherever
skipped
you
this
save the
step.
file.
Sorry. So here, where I'm editing the code, is in a text editor. You can use Notepad, Notepad++, Vim or Emacs. Whatever you use Vim or Emacs, you've known to be in a text editor. Yeah, WordPad. I don't know. Whatever text editor you have. You want to actually open your collab file up in that, and then edit, and then we're going to run the file after we save it. So I'm going to help someone really quickly.
No, I don't know Python enough to fix that syntax.
It was on line 46.
No.
What's the typical line 46?
Yeah, that's what I'm good at. Yeah, 2.7.
Every time you do Python, make sure it's.
I don't see it, but I know it's there.
So it has like the library.
It's my desktop. It's like my desktop.
Maybe you just
What's the change in date? Oh, you know why?
Why?
Yeah. Okay, so mine's probably run. I think I must have posted it later version. So, oh, well, I told them I was too, so it's not bad.
It's a new generation change.
46.
No, but the guy over there is I mean, it's just a.
Okay, you guys, I apologize. I may have posted a earlier iteration of this. So it only has a couple of surface things. So yeah, on 68 is this, liker instead of like.
I think it's the one that's collab.
60, they should say like.
Yeah, comment instead of commenter. Yeah, comment. Oh. So okay, actually, so on 68, what you need to do is copy what's in append, this like ID, and put it here, and then copy this comment from ID and put it where commenter was on 74. I'll leave that up for a little bit. I apologize. I will post the updated ones to GitHub.
Wait, what are we changing?
So we're changing. Here, let me make this bigger. Oh, I don't use this computer. Okay, so anyways. So we had liker right here, it should be like ID, which is within append. We have commenter right here, it should be comment from ID. I don't think I might have made one more change. Sorry, the only reason I'm doing it this way is because otherwise I have to get her off the computer and then.
So just change liker to a like ID and commenter to a comment ID.
So the comment, what's it say? Comment data ID or something like that? Comment from ID. Oh, where did I download this? I downloaded this.
I have the same.
Okay, did you guys change that? What does it say?
It says I have an error on line 73 that it doesn't like comments.
Oh yeah, so you should change comment. Oh, for comment. Huh. That should be fine.
It should be comment from ID.
Wait, what? Okay, I can just download that and post the new one. Because that would run.
Yeah, the original form.
Yeah, you get out.
Yeah. Comments. And the clip that I'm on.
No, mine's from the light.
Did you ever?
Okay, well, this is a fun game. I fixed all these errors on the bus on the way here, so we'll see if anyone can give me a time. But of course, I wrote the code. So it's following me naming something wrong, like
Is yours run?
yeah.
What yours is
Unseen post.
So,
On
in Python, it
Yep.
expects everything to be one, so instead of reading things, it's like two things that happen.
Expecting oh, sweet.
status.
Oh, because it seems easy.
It's definitely easy.
Well, like this, so it should be
Like
what's in
there's
the
stuff
name.
we define. We're trying to get the actual.
Right. So after the 4, whatever you wrote is fine, right? But it's in this if you just have no similar no letters. Oh, just return.
From future reports, he's like,
I changed that.
Use spaces. I didn't put that for So,
I'm saying something.
Wait, so you
Change this right here, this
It runs.
there are cases.
Yeah,
there are cases where you
status.
like it runs.
It's not mine.
But then mine is
So I can post this updated one.
But get around. No, it's counting. It's finding similar friends. I just don't like you. John,
there should be no comments except for in status.
Yeah, you for comment.
and then you I have a bunch of comments. No, it says how many friends you check. What is
But mine gets stuff in different places.
we have it print
This gets stuff on likers, mine gets stuff on
I don't know. It's like looking at light in something. John, I think I got it. I think
You're missing an N.
Yours run now?
Okay.
Yeah, we go.
Feedback. Likes and
Only kind of thing out
You get the same thing.
Okay.
The problem is,
This one is the one you're getting? My 24 friends, close friends. I get that.
Alright, it's on my notes now.
you hit the maximize button.
Oh, he's coming in and code editing.
What is this? Emergency.
First one's get it to run, get the cane.
Why is this in my baby? No!
What happens when you get a key?
R. I don't know.
Yes, you know how to use it.
What is this? And why did it come up with
It's one of your friends. No, it's one of your friends that it thinks you should play.
Okay. No. Isn't there a programming language?
But Sean, go find one of your friends on Facebook and post it back. Just search for like, does anyone, oh god, mine is R.
Anyone know how to use R? I know how to use R.
Joe's friend, so Joe's friend is going to go to R.
I'll go.
No, that's good.
Wait,
I found it. I found it right there.
It doesn't even know how to use it. Oh, it's a stats. R is a stats.
Oh, down
okay.
Is it SPSS? SPSS is
Yeah, it's really weird. So I had it running just here. Let me find all this.
Can you just commit?
Well, I'm trying to find it now.
I got mine running.
And also,
The running free?
culture yours.
The running free?
So there's a lot of
Even, you know, just like more than being cultured. Spending money to get culture.
Yeah.
You get culture. You can get culture.
Yeah, so now I'm getting.
I feel like high school.
I just want to start my own little
That's not.
Scrolling and yelling. I don't know what culture you're talking about. Yes. No, not the four Gators. I know we won. I know we stomped them into the ground like a.
Yeah.
He does. He didn't do as well as the election.
That means we're doing
Wait.
Yeah, exactly.
Yes.
Okay, so one thing I had in here, which I think is the thing that's catching, we need to make sure that it has light in class. So if status,
I know that
that
it's
keys,
really, it slows it down, but I need to get it. Oh,
so I apologize for this. I had it running on here, and I must have shut it down and not saved but right.
They still managed to stomp all over you.
How did they lose the starter? There was a lot of
No. It was like this pencil, and it was like.
There's a lot of
You think they can't keep the emotion going? Maybe they should have another player snap their leg in half.
just where he close. I think if we win, I think whoever comes first is
Thank you for happening.
Okay, yeah. Looks like it's ready.
I really want to.
What did you change?
So, I will show you. Oh, actually, I guess. So, oh no, so mess. Okay, so one thing you need to change. So about line 64, the problem is this. So you might have people's statuses that don't have either a like or a comment. So what we need to do is we need to continue. So go to the next status if one of those is the case. So what I said is if likes is not in the keys for status, colon, continue. And I'm going to post this new file up when I figure out what this last error message is. I apologize for doing that. So status.keys, open and close brackets.
I just had to divide by zero.
No, it's more than that. Oh, and after that is because yeah, the same thing. So then I'm going to say the same thing.
No, it's similar to me. I got divided by zero.
Status.
At least you're friends. We should create like a machine learning troll thing for you.
Yeah.
Did you guys get it?
Auto troll. Figure out what people like and then
It's an infinitely percentage. Or maybe I just wait it. Just to go through my whole friends.
Bernice, I think the 6 and 7 issue still exists.
Oh, it's just taking a while?
The 6 and 7. Oh, yeah.
I feel like it would already.
Mine already failed, but then apparently my total sin must have been divided by zero.
I'm going to run this one. I mean, I did it. I just did it. I don't remember the
Which is confusing, but I'm pretty sure they go wrong.
I'm sure I had to get stuff.
So you should be done. Also, I had to move you.
It's not
to the top.
Ooh la la. But
I'll give it like another hour.
a couple hours.
What is Nate Silver saying about this?
What did you guys change?
I think it doesn't like it.
I never actually finished this.
Okay, you guys, I think it's going to run.
Or I'm sad, let's see, lose money.
Just take it. If you get a divide by zero here, does it mean that no one likes you?
It means that you have nothing in common with your
With
friends.
anybody.
Because you have no situations in which your friends
In the
and
past,
you have
7
the
days
same
or
thing.
whatever, though.
Oh,
Well,
that's
yeah,
true.
that's true.
Oh, maybe I should change the date.
No,
Still
because I
good.
did
Well, no,
that
you
because I
should
felt
probably
like
just remove the
yesterday.
source of the error. That might be a little more simple.
Show the changes you made at 64.
If you don't like people's statuses,
So if
I don't like
total
people's
sin is not
I find your stat, all your stats.
Damn, I was using the channel.
I was using the royal you.
Maybe my min-life threshold is too high.
It's just like it's just like super.
And we'll what did that do? Yeah.
Oh, you got the same thing?
Yeah.
Excellent.
We'll see. It's going right now. It's checking.
Does it take a long time?
And it takes like a minute.
I don't know where my
The
errors
problem,
are.
okay, so there's a lot of ways to make this faster. I wanted to make it readable, which makes more sense than making it faster. So I will let this slowly run and not watch it. Line 64.
66.
The three
Right here.
Okay, so
likes.
at line 64, you just want to make sure that if there's no likes, if there's no comments, and if there's no, this should be message. I guess it's messages.
I read mine.
What's messages?
Really?
What is message?
Well, then all of your friends like or comment on all of their statuses. Or at least the ones that will last.
They're like me.
However long.
No, I ran it without line 67.
Oh, without the messages one?
What is
Okay,
messages?
I had that. Yeah, conceptually it was really weird too. So this idea that if you have a status but it doesn't have a message, which the only way that would work is a lot of my friends send pictures with absolutely no words. That's what a message is. It's it for random.
No.
Yeah, it's in there.
Why did I get the roll?
Do I need to do the messages thing?
Is it because we don't fix it?
Just have to display
Okay, let me try something.
You still hacking what you
Yeah, that's
Just redraft the code.
Or just change it to zeros.
Well, let me push this code right now. I'm gonna see if it runs. Or push this code that doesn't run anyway. But if it runs, I'll push it right now.
Yeah, so that's the error I had before that was.
I didn't see it.
Here.
Okay, so,
It's the same thing you have, but I got it in your
oh, let's stop the last slide of my presentation.
So keep going.
For the game. Oh. Okay, so I'm gonna actually come up with some situations, and we're gonna try to figure out whether or not it's gonna be collaborative filtering, or classification, or clustering. While I let this run. Why is it pushing? It's not pushing NG for you?
I got it.
Mine
Mine's not even getting
Mine's best run.
Yeah. Yeah.
If you divide by zero.
No, I don't. It just tells me my friends is stuck in a loop somewhere.
Are you emailing it to me? Or
Did you add both those things?
Why don't you just make it just?
Yeah.
I'll check.
You're gonna get my minus 1-0.
Is it spelled messages, or is it just message? Because if you put in messages, that could mean it's not any of them.
Oh.
I think it's message, because mine went through, I still get an error
Yeah,
somewhere.
it's message. Good job. Bernease, BERNEASE at Amish.
So if message.
I refuse to use anything that I can't
If
get my
comment.
first name.
Oh, wow.
Or
See, you
comments.
just hit 380.
What is it saying?
Okay, let's run it. See.
Give likes, you give
Okay.
On those three? Yeah, it's likes.
Likes, comments, and message.
Likes, comments, message.
Message.
See if it runs. Okay, so while I'm waiting for this to run,
Message is
just
the
watch
only one
it.
without.
Oh no! Oh,
Makes
this is
perfect
a couple.
sense.
That's what I got.
Okay, so this is the other thing.
Yeah, which makes sense.
This is a tuple in what line should it be? Okay, I swear it didn't change. Okay, so line 102 for me, it might be a little different depending on how much space you put. Make that a list and not a tuple.
I think the key is like
Save it.
Or even this is just saying that.
Okay, I'm gonna run again. Okay, so really quickly, sorry we're running over a little bit, but does everyone get the difference between clustering, classification, and collaborative filtering? Do we want to look at them again, or do we kind of get it in our heads? Okay, so if I ask you a question about our Facebook data and trying to do something, you guys will be able to tell me? Okay, so let's say I have, well, let's say some of the other things that had I had time to have gone over. Oh, it runs. Okay, you want me to push this? Oh, except this is, doesn't, gosh darn it. Okay.
What did you change there?
Hmm?
On 102.
So I'll just briefly go over the changes and that was it.
It's just on that line.
So from future needs to be at the top. So in 63, you need to add these. And make sure it says message and not messages as I put earlier. And then we have a tuple somewhere that I changed to a list.
Right,
so
yeah.
Here, 102, append, we want to put this in a list, so the square brackets. Because you can't you can't index a tuple. Okay, so the problem is I don't even have Git. Well, I have Git. I have to put in all my settings. I don't even have Git on this computer. Okay.
It's not quite the same.
I didn't have to do the square bracket. It now just becomes
Really?
a search. Okay. Well, it's
Yeah.
It's on the Facebook too.
Oh, it's on the Facebook
On the
group?
Facebook event.
Okay, so on the Facebook event, I'll just push mine up just
two is bit number. So two. Yeah.
You can write over the
two is bits.
Oh,
Right.
okay.
Yeah.
Where's Facebook?
So it doesn't.
Alright, so Facebook,
I didn't look up the other.
we'll go to the event.
Search them using.
I don't know why someone put a box on the top.
You might have to do two animals every time. Oh, says not possible to store me in
Oh, so not sign it? Yeah.
That's
You might not be able to edit. I don't know how it's just. I can edit.
Well, okay, I'll just,
some of them might be. In fact, then you just don't store zero.
Just don't start zero. I'm going to multiply two numbers. We're not going to store the zero.
Can you just use the JavaScript?
No, my favorite line of code is
Select all.
okay, so let me push this spot.
what?
Did you try to code it up?
I didn't try it.
Fire trying to give it time. It's like
Okay, so just to show you guys how this is working,
all those zeros are
I've been
not
showing all zeros.
If you double your possibly I got rid of all the Whoa. Oh my.
Oh, how I love lots of real crime roads, heaven. Oh, these are also zeros here.
No, just
That's what I did.
What's the sorting algorithm?
Okay.
You can only ask. Well, no, it replicates sometimes. Let's say I have a memory. It doesn't have a reverse. You can just check to see if there's something.
Auto. That code works that you just posted?
Yes.
Yeah, the one that I was
Order the
Yeah.
I could order.
What to do? Well,
Good job.
stupid computer, I never use this.
First we can break the law.
Posted on Facebook.
How?
Right.
It's not two-dimensional, it's only
I
one-dimensional.
didn't get enough.
What's two-dimensional? I got two numbers.
No, you don't. You convert each one to the law of the
Makes no sense.
But it doesn't matter, there's still two.
There's still two numbers, it's still two-dimensional.
You have two numbers.
And then add the logs.
And then
No.
That does make sense.
What's the problem with this? There is a problem. Oh, yes. The lookup table is way too long.
Do you know if there's any,
They're used interpolation.
do you know if there's any open rooms?
Good, you guess.
It's like
Watching with the classroom?
Exactly. Exactly.
Oh, yeah, I'm so quick. I'll just try and go this outside.
Steve is more of a determinist.
Actually, no, you know.
How do I get the SCV to mine?